Good morning, everyone, and welcome to today's lecture. This is lecture number 3, and we are dealing with work, work done by forces. And in the previous class, what we had seen was some important points about work done by a force. And we had seen that work done is always defined for an interval. It does not depend on the type of
Sir, we
motion.
are unable to hear your voice.
I think from my side, everything is clear. I don't know. Uh, is everyone able to hear me? Yes or no? Boys,
Sir,
see, I'm good. No trouble from my end. Trouble is at your end. So just check out your system there. I'll give you 2 minutes. Check it out. So as I was saying that we were dealing with important points about work done, and you must remember these points because any of these points could eventually come into your exam. The last point was if the displacement of different parts is different, the work done by the force is actually force dot the displacement of the point of application of force. So remember this concept. Now even this displacement is not exactly correct because there could be a force where the work done, if you try to find it out with displacement, it is going to come wrong. And what is that force? That force is your friction force. So remember, work done by friction. Now, friction is a very special force because this force continuously changes its direction according to the motion. If the body is moving towards right, it is towards left. The body is moving towards left, it is towards right. So it keeps on changing its direction. So it keeps on changing its direction. So remember, if I have a body which is kept on any floor, anywhere, and I move this body from point A to point B and then back from point B to point A, the work done by friction is not going to be zero. If I move it in a circle, the work done by friction in one complete circle is not going to be zero. The formula will tell you that it is force dot displacement. The displacement is zero, therefore the work done would be zero. So remember, in case of friction, don't use F dot displacement because that might not give you the correct answer if you are moving in a circle, or for that matter, if you are moving in a straight path and then you are coming back. Work done by friction, if you try to find out with force dot displacement, it will not come correct. So for in case of work, you will always find to find out work done by friction. For work done by friction, you always use force multiplied by the distance traveled. And here you will use cos of 180, so you can write it as minus Fn because force is always going to be opposite to displacement. It will not be at an angle also. The frictional force is at an angle. The body is moving like this, frictional force is acting like this. It will not happen. So remember, for friction, do not use F dot displacement because that will not give you the correct answer. Always use force multiplied by the distance traveled and not force multiplied by the displacement multiplied by cos of theta. Do we understand this? Because friction is a special force, it keeps on changing its direction according to the motion of the body. Now, again remember, now this friction is an action reaction force. This friction is an action reaction force. This, this friction is an action reaction force. Therefore, work done by friction on the two bodies will be opposite. What do you mean by opposite? When I say opposite, if it means on one it would be positive and the other it would be negative. Say for example, this is a floor and you have a body of mass capital M kept on the floor, and there is a body of mass small m moving with a velocity v on the top of the other block. Now see what will be the direction of frictional force on the top body. What will be the direction of frictional force on the top body which is kept on top? What will be the direction of frictional force on that body, and what will be the work done? Will it be positive or will it be negative? Waiting for your answers. What will be the direction of friction on the top body? No one knows it? It is such a difficult question that no one knows it. Okay, then you go back into the chapter on friction and see what is the direction of friction. I will give you 2 minutes to go back and have a look. 2 minutes, go back, tell me the direction of friction. Yes, so we have any answer for the direction of friction? The body is moving towards right on the top of the first body. What is the direction of friction on both the bodies? Right or left? Number one is right, number two is left. Can't see.
Left.
It would be left. Thank God, I got an answer finally. I thought that I will never get an answer. So direction of friction would be towards left on the top body. What will be the direction of friction on the lower body? Right or left? Lower body, the body on which this body is kept. What will be the direction of friction on that body? Right or left?
Right.
Right. Now tell me what will be the work done by this friction? Will it be positive or will it be negative? The pink
Negative.
friction, will it be positive or will it be negative?
Negative.
It will be negative. Great. It will be negative. Now tell me, where is this green body going to move? Where will this green body move? There is no friction between ground and this green body. Where will this green body move? And who is moving this green body? Where will this green body move?
Right.
The green body will move towards right. The green body will move towards right. And why it is moving? Because of which force is this body moving?
FK.
Because of frictional force. So friction does not oppose motion. Here it is causing the motion. And therefore work done by this friction, which is the blue friction, work done by this blue friction would be positive or negative?
Positive.
It would be positive. So remember, Work done by friction on one body, if it's positive, then the next body, it would be negative. Do we get this? Yes or no? But whatever positive work one body is doing, friction is doing on one body, and whatever negative work friction is doing on the other body, they will not be same. They may not be same. Therefore, the total work is not zero. Do we understand this? We understand this? Yes or no? Do we understand this? On one body, friction is doing positive work. On the other body, friction is doing negative work. But the net work is not going to be zero. Now take the example of this body. It is moving with a velocity v. What is the direction of frictional force on this body?
Sir.
It would be towards left, sir. What about the work done by this friction? Will it be positive or will it be negative?
Negative.
It would be negative. Great. Now, the other body in this case is ground. What is the direction of friction on ground?
It's
The direction of friction on ground would be forward. Now, what is the work done by friction on ground?
positive.
Is the ground moving because of frictional force? Is the ground moving because of frictional force? And that would be great, na? Why we have to move the body? Let us move the ground. है ना? I again ask the same question. What is the work done by friction on ground here?
Zero.
Zero. So please understand this. In this case, the work done by one friction is positive and the work done by other friction is zero because ground does not move. Ground does not move. So remember, whenever we're talking about work done by friction, you have to be careful because it could be, first of all, you have to understand that you don't have to use displacement because if I move it from A to B and B to A, work done by friction is definitely not zero. Then if there are two bodies, work done by friction on one body may be negative, the other body may be positive, it can also be zero. As in this case, both of these things I have told you. Do we understand this? Yes or no? So friction is a special thing. You must understand the work done by friction. Okay, now since we have done work done by friction, let me take the other forces as well and let us try to understand the work done by various forces. So let us do that. Work done by N. What is N? What is N? What is N? Huh?
Reaction.
N is?
Normal reaction.
N is normal reaction. Now, whenever you have a normal reaction, you have a body kept on horizontal surface and the body may be moving or the body may be on an inclined surface. The body may be on an inclined surface and then the body is moving. Or the body may be on a zigzag path and then the body is moving. What is the work done by normal reaction in all these cases? Yes, bacha. What is the work done by normal reaction in all these cases?
In first case, 0, sir.
In first case, 0, sir. Second case? Third case? Yes? First case, work done by normal reaction is 0. Case number B, what is the work done by normal reaction? Yes?
0.
Why it is 0?
Perpendicular.
Okay. Does it take so much of time to reply this answer? What is the work done by normal reaction in the third case? Positive, negative, 0, what? I'm waiting. There are only 3 options. Someone say positive, the other one will say negative, the third one will say 0. So out of these 3, one of them would be correct. Yes? I'm waiting. Okay, I'll give you 2 minutes. Think about it. Let me know the answer. Yes, do we have an answer? What is the work done by normal reaction? Case number 1, 0. Case number 2, 0. Case number 3? Case number 3. You want more time? Okay. I'll give you more time. Yes, tell me. I heard something. Do we have an answer here, beta?
0, sir.
0, sir. Okay. Why it is 0? Any reason why it is 0? There must be a reason why it is 0.
Always perpendicular.
It is always perpendicular. Okay, great. So work done by normal reaction is always going to be 0 because this normal reaction will be perpendicular to your displacement. The body is going to move along the plane. Normal reaction is perpendicular to the plane. Not going to move up and down. I hope you have forgotten it. Body does not move up and down on the plane. It only moves along the plane. Normal reaction is perpendicular to the displacement and therefore the work done would be 0. Why did it take so long for you to answer this? I am yet to find out the answer for that one. Anyways, I will leave it at that. Work done by normal reaction is going to be 0 in all the cases because normal reaction is going to be perpendicular to the displacement. I hope all of you are working, all of you are solving questions, and all of you are trying to do questions. Okay, that takes us to the next one. Remember, this is one of the easiest topics in mechanics that we are encountering. So everything in this topic must be very true. If there is any problem, Either you tell me that we don't understand it, so I will try to make you understand. If you don't tell me, well, I will just move ahead, and this topic would be left behind. So it's all up to you, beta, how you want me to do. If you don't say anything, I will just move forward. Why will I stop when I think that you have understood this? Work done by tension. The next thing is work done by tension. And again, I'll give you chance to discuss and tell me the answer. Even if it takes 15 minutes, 20 minutes, even my entire class goes in getting one answer, I will wait. Don't worry. I have a lot of patience. What will be the work done by tension if I move this block or if I move this body? And these type of questions are going to come a lot of time. What is the work done by tension? And you swing a body like this. What is the work done by tension? What is the work done by tension? On this block? Yes. What is the work done by tension? Block number A. It's a pendulum. I have a bob attached to a string and I move it. It moves like this. What is the work done by tension? And the answer would be 0. Why it is 0? Why is the answer 0? Yes? Is everyone there? I hope I am audible and visible to all of you. And probably I'm asking question is not reaching to all of you. Why is the work done 0? Can everyone hear me and hear my question? Yes or no? Yes. So what? Why it is 0? Someone told me 0. Why it is 0?
Perpendicular to displacement.
So speak out, na. See, if you don't speak out, that means you have not understood. If you have not understood, I will have to stay there unless until I get a response. I will not move forward because what I have learned from you guys is whenever I ask you, everyone understood. All the hands are up. But after 2 minutes, if I ask a question, everyone is looking here and there. So now I will not ask you to raise hand because I know that everyone will raise hand, but no one understands. So now I will ask you questions, and if I don't get an answer, I will stay there. So here the work done by tension is 0 because tension is perpendicular to your displacement in all cases. Let us take another example. This is a body of 5 kg. This is a body of 3 kg. How will these bodies move? This might remind you of something that we had done some 15-20 days back. Yes. How will these bodies move? How does this 5 kg green body move?
Downward.
Down, right, left, where?
Downward.
Downward. Great. This body moves downward. If it moves downward with X, what will happen to the pink body, 3 kg?
It will move upwards, sir.
Chalo. It will move upwards. If this body moves downwards with X, how much will this body move?
X.
X. Okay. What is the work done by tension on this block and what is the work done by tension on this block? On the green block and the pink block. It is a very simple question.
minus Tx.
Minus Tx. So the work done by tension here is negative. What about this one?
Plus Tx.
Plus Tx. Now if I ask you what is the total work done by tension on this entire thing, what is the total work
0.
by tension? Zero. Work done by tension is zero. Tension, whether it is moving like this or two blocks attached, the work done by tension will always come out to be zero. Have we done this before? Work done by tension is zero. Have we done this before?
Sir.
Yes, do you remember this? Oh, that's a surprise. Where did we do this? That's a surprise. I thought that you will say no. Where did we do this?
Constant motion.
Where?
Constant motion.
Sorry, I did not get you. Beta.
Constant motion.
Constrained motion. So we did something like constrained motion. I forgot. I hope everyone remembers it. Work done by tension is always going to be zero, and that is what we use in constraint relation to find out how much is the relation between this and this and this. That is how we found out. So work done by tension is always going to be zero, whether it is applied on one body. In example number one, it was applied on one body. Example number two, it was applied on two bodies. You could have more than two bodies applied, more than two bodies tied to a string, different strings. In all cases, work done by to net work done by all the tensions would come out to be zero. Do you understand this? Yes or no? Chalo. No, I should not ask you that because everyone understands this, but no one replies. So I will not ask you that. Okay. Next thing, let's move ahead. Now let us move on to the third force which is going to come. Work done by gravity. Our favorite force, gravity. Work done by gravity. Work done by gravity. A body of mass m is here. It is at a height h. If I drop it, what happens to this body? If I drop it, what happens to this body? If I leave it, what happens to this body?
It will fall down, sir.
It will fall down, sir. So that means it is moving. So work is being done. What is the work done by gravity in this case? Case A, work done by gravity. I should not take rocket science. It is a very simple question.
mgh.
Plus or minus?
Plus.
Plus mgh. Okay. Let me change the scenario. And let me make it like this. This is theta. This is, let us say, height h. And this is m. There is no friction. I leave this body. What happens? What happens? What happens if I leave this body?
Slide down, sir.
It will slide down, sir. Okay. It will reach the bottom. What is the work done by gravity in this case? Case number B. What is the work done by gravity in this case? Hmm? What is the work done by gravity in this case? You can find it out in any way. It will come as plus mgh. It will come same. Then I have this block and I allow it to fall down. It fall down from the height h. What is the work done by gravity in this case? It will be equal to plus mgh. It can be proved and I'll leave it. I'll leave the proof to you. So what do we understand from here? What do we understand from here? Work done by gravity does not depend on what? Does not depend on path. How the body is falling, it does not depend on path. It only depends on its initial and final positions. Work done by gravity is positive when it is moving down. Work done by gravity would be negative when the body is moved up. Work done by gravity will be zero when the body is moving how? When will the work done by gravity zero? When the body is moving horizontally. Work done by gravity will be zero when the body is moving horizontally. And work done by gravity is always equal to plus or minus mgh. What is h here?
Height, sir.
H is the height through which the body has moved. If the body has moved up, work done by gravity is negative. The body is moved down, a height h, the work done by gravity is plus mgh. It does not depend on path. The body is moved horizontally. Work done by gravity will always be zero. Gravity only does work when the body is moving up or down, and it does not depend on path. Again, work done by gravity in a closed loop. What do you mean by a closed loop? What do you mean by a closed loop? Anyone? Work done by gravity in a closed loop is zero. What do you mean by a closed loop? I move from A to B, then to C, then to D, then to E, and then back to A. This is a closed loop. So I start from one point and come back to the same point. That is a closed loop. Start from one point, come back to the second point, closed loop. Work done by gravity in a closed loop is zero. Work done by gravity in a closed loop is zero, and we can easily understand it. If I say this point is A, and if I say this point is B, when the body is moving from A to B, work done by gravity is plus mgh. When I move the body from B to A, the work done by gravity is minus mgh. So in all, the total work done by gravity, downwards plus mgh, upwards minus mgh, in a closed path A to B, B to A, it is going to be zero. Whatever happens, no matter how the body moves, if the body goes from A to B, in this case, the work done is plus mgh. If I move it from B to A, work done would be minus mgh. Work done by gravity in a closed path is zero. If I move it from here, A to B, work done by gravity is plus mgh. If I move from B to A, work done by gravity is minus mgh. In a closed path, A to B, B to A, or in any type of closed path, work done by gravity is zero. Such type of forces are known as conservative forces. Such type of forces are known as conservative forces. What are conservative forces? Such type of forces are known as conservative forces. What are conservative forces? Anyone can tell me now what are conservative forces? What are conservative forces? I gave you an example. Now can you tell me what are conservative forces?
Gravitational force.
Yes?
Gravitational force.
Conservative forces are those forces whose work done does not, and I call it C. Work done by C. C means conservative force. Work done by conservative force. What is the first point that you must remember? Work done by conservative force does not what?
Does not depends on path, sir.
Does not depend on path. Work done by conservative force does not depend on path. What is the second thing? Work done by a conservative force in a what? Work done by conservative force in a closed loop. Work done by conservative force in a closed loop is equal to zero. Examples of conservative forces. Can you give examples of conservative forces?
Gravitational force.
Gravity or gravitational force. Then spring force and electrostatic force. These three forces are conservative, which we will come across. Gravity and spring force in this year, electrostatic force in the next year. Gravity, spring force, and electrostatic force are conservative forces. All conservative forces, all conservative forces are associated. All conservative forces are associated with potential energies. So wherever there is a conservative force, there is a conservative force, there is a potential energy. Work done by this force, work done by the conservative force stored is stored as potential energies. Work done by the conservative force is stored as potential energy. So when you do When a conservative force does any work, it is stored, it is not lost. You can get it back. Examples: gravity, spring force, electrostatic force. Any constant force is always conservative. So remember this. Any constant force is always conservative. If a force is constant, does not change, it is always conservative. That means that force will not depend on path. Any constant force, any force which is constant is conservative. It does not depend on path. These are conservative forces. Then we have their friend or their opposite. What would be their friend or opposite known as?
Non-conservative force.
Non-conservative force. So what is the first point that you must remember about a non-conservative force?
It depends on paths.
Yes. Work done by NC, non-conservative. Depends on path. Second point. Work done by a non-conservative force in a closed loop will be how much? It's not equal to 0. It will never be equal to 0. If I start from point A, go to point B, then I go from point B to point A, work done by conservative force will be 0, but work done by non-conservative force will not be 0. Examples of non-conservative forces.
Frictional force.
Just gave you an example. Friction force A to B, B to A, it is not 0. Frictional force. Friction. All resistive forces. Viscosity. Air resistance. All these are non-conservative forces. Do we understand this? So, for this non-conservative force, you will have to see what path you are moving because they depend on path. Do we understand this? Yes or no? We understand this? The points about conservative and non-conservative forces. Be ready because tomorrow when we come, I would be asking you questions based on this. And I will not answer them. I'll wait till the answer comes. If the answer does not come, maybe the entire question, maybe the entire class will go on just one question. So I'll ask questions and you will have to answer. Well, you have to understand the concept of conservative and non-conservative forces because this is not in this chapter, it is going to come. It's going to come in the next to next chapter, in the next to next chapter, then again, then again, then again, then again. We'll keep on coming till 2 years. This chapter forms the basis of one of the most important concepts in physics. The law of conservation of energy and all these work energy theorem, everything starts from here. So this chapter has to be very clear in everyone's head. That is prime important. Because if this chapter slips away, one of the easier chapters slips away in mechanics, becomes difficult to do any question. The next chapter which is going to come, collision or rotation, even if you become champions in that, there is no guarantee that you will be able to solve a question 100%. But here in this, there is almost 100% guarantee that if you understand this, you will be able to not only solve question of this chapter, but other chapters which are coming ahead. So therefore, you have to pay full attention to this chapter and I hope that you will do this. And if you don't understand anything better at any point in time, please ask me. I'll explain it 5 times, 10 times, 20 times, 50 times, doesn't matter. But if I don't get an answer, that means whenever you raise hand, you did not understand it. I asked you the direction of frictional force, no one knows the direction of friction force. No. That means the entire thing that we've done in friction is waste. Because if you can't tell me the direction of friction force, what else can I expect? That was the first thing I told you, and I gave you so many examples. So please be prepared that friction is over. That does not mean that friction will not come again. Friction will come more in this chapter rather than the previous one. That's the problem with physics. Things keep on coming back. It's like a bad dream. It always comes back. Good dreams never come true, but bad dreams are always haunting you. Bad dreams in physics are same. So it's a bad dream and we have to live with it unless until we may make it a good dream. If it is a good dream, it will never come back. And that is what physics should be, not a bad one. So on that note, I will end today's class that physics would now behave as a good dream and not a bad one. Take care. God bless all of you. Bye bye.
Yes, sir.
Tata.